Check if the region of operation for the following circuits. Determine the operation point if it's in saturation. Assume lambda is 0 and these values are given. Let's look at the first circuit, 3A. Some of the solutions for other questions will be in other video link. For 3A, this is an NMOS transistor where you have 15 volt here and minus 15 volt. This is your gate connected to a 1 mega ohm resistor. As the current going in or out of the gate for MOS transistor is 0, if this point is 0, because the current flowing across this is 0, so the voltage drop across this is 0, then if this is 0, which is in this case, this point VG will also be 0. Okay, let's look at the solution. As mentioned, there's no current flowing into the gate, hence VG is equal to 0. The voltage here is 0. Let's write a KVL equation from this point and downwards. As we know, the voltage here is 0, so VGS plus the voltage drop across this, which is VGS plus ID times RS, is equal to 15. We can rewrite the equation to be this, where RS is 3K and ID is in milliamp. For MOS transistors, as the saturation region is the main operation region, always assume it is in saturation mode. For saturation mode, we can use the equation for the current ID for NMOS in saturation mode. As lambda is equal to 0, we get this equation. From the question, Kn, Vtn are given. With equation 1 and equation 2, substituting equation 1 into equation 2, VGS is substituted into here. The equation ID can be obtained. Rearranging the equation and solving it using quadratic equation, where A in this case is equal to 1, B is minus 9.78, C is 21.78. Solve it using the quadratic equation, we can obtain the two values of IDs, which is from the plus and the minus sign. ID is equal to 6.35 milliamp if you use positive here, and ID is 3.43 milliamp if you negative here. Substituting the values of ID equal to 6.35 into equation 1, we can obtain VGS to be equal to minus 4.05. As mentioned, this is an NMOS transistor. To turn on an NMOS transistor, the gate voltage has to be higher than the source voltage by VTN. And in this case, VG is 0 volt if VGS is equal to minus 4.05 volt. It is not acceptable. As VGS is smaller than VTN, the transistor is off. When the transistor is off, there is no current. ID is equal to 0. So the answer, it is not acceptable, okay, for ID equal to 6.35 milliamp. Let's try ID equal to 3.43 milliamp. The same method, substitute it into equation 1, obtain VGS. It is 4.71. As this VGS is larger than VTN, which is 1 volt, it is acceptable and is on. Let's find the voltage VDS so that we can check the operation region of this transistor. VDS is the voltage across this. It is simply VDD minus the voltage drop here, which is ID, times this resistance RD, minus the voltage drop across this resistor, which is RS, times ID, and minus the voltage at this point, which is minus 15. 15 and minus 15 becomes 30. And combine these two, you get this. VDS can be obtained to be 16.28. As VDS is 16.28 volt and ID is 3.43 milliamp, we can double check the operation region. If VDS is large, how large? If VDS is larger or equal to VGS minus VTN, then the transistor is working in the saturation region. VDS is obtained just now to be equal to 16.28, while VGS is 4.71, VTN is 1, 4.71 minus 1 will give you 3.71. So this side here is indeed larger than this side. This means the transistor is working in saturation.